For page 39, just paste the piece of paper that has both the remainder and the factor theorem on there, and that's going to be the title of this page. And so the remainder theorem is going to be a little confusing at first because of all the extra letters, but I'll try to explain it when we do a specific example. So the remainder theorem obviously has something to do with the remainder of either a long division or a synthetic division, either one. It says if a polynomial p of x is divided by x minus c. So the polynomial would be the dividend, x minus c would be the divisor, c is just going to be some constant. Then the remainder is p of c. What that means is that if you were to plug c into the original function, the remainder will be the value of whatever that y value is. It will actually be the exact same thing. So let's show this with an example. This says to calculate f of negative 4 if f of x is equal to 2x cubed plus 3x squared plus x using the remainder theorem. So to calculate f of negative 4, you were taught in Algebra 1, pre-algebra, substitution. You would take the negative 4, everywhere you saw an x, and you would just simply plug it in, and then it come up with the answer. You would find the y value that belongs with that negative 4 for x. Well, this is saying to do this same thing but using the remainder theorem, so we have to follow the directions. Well, in this case, our polynomial, p of x, is going to be our f of x. So that's what the polynomial here is from the remainder theorem. And then the remainder is going to be equal to p of c. Well, this right here is going to be like my p of c. Since the function is p of x, I want to know specifically for c equals negative 4 when I plug that into my p of x. I'm going to be dividing this by x plus c. My remainder is going to, not my remainder, I'm sorry. My c is going to be the value that's inside the p of c, so negative 4. So therefore, I would be dividing this by x minus negative 4, which is the same thing as x plus 4. So that's going to be my x minus c. So I could use long division. I could take x plus 4 as my divisor, and I could use f of x, or in this case p of x, is my dividend, and I could figure out what the remainder is. You're more than welcome to do that and try it. Remember, synthetic division is a lot faster though, so I'm going to go ahead and use that one instead because it takes up a lot less room and it's going to be a lot faster. So I'll put my negative 4 on the outside of my box, and then my coefficients, which in this case are 2, 3, 1. Notice there's no 0 for the constant, so if I don't put that on there, I will get this wrong. You have to put every single term in there for synthetic division to work. So if you want to go ahead and pause the video now and see what you get, that's fine. So now I'm going to start, and then when I do my synthetic division, this is going to be my result. So this is what you should have gotten. So in this case, my remainder is negative 4. According to the remainder theorem, the remainder, which is negative 4, should be the exact same y value that you would get if you would have plugged negative 4 into the original problem. Well, let's check it. Let's see if that's true. So what we'll do is we'll plug in negative 4 into the original. So 2 times negative 4 cubed plus 3 times negative 4 squared plus negative 4. Negative 4 cubed is negative 64 times 2 is negative 128. 4 squared is 16. 16 times 3 is 48. So we're going to subtract that. 128 minus 48 is 88. No, 80. 80. Negative 80. Because this was a negative 128 and then this was a positive 48. So it's going to give me negative 80. And negative 80 plus negative 4 is negative 84. So it is true. And this is all we had to do from the very beginning was plug it into the original problem, but because it said using the remainder theorem, I had to do either long division or synthetic division to figure out what the remainder would be, and that's the value of my function. The second theorem is factor theorem. This one's kind of a duh type theorem. We've actually been using this even though I didn't really say that's what it was called. The factor theorem just basically says that if you get 0 as a remainder, then the divisor that you were dividing by is a factor of p of x. That just means it goes in there evenly, which makes sense. So this problem says to determine if x minus 1 is a factor of 4x cubed minus 3x squared minus 1. Again, I could use long division here. You're more than welcome to use that if you're more comfortable with it. But I'm going to go ahead and use synthetic division because it's a lot faster. So I'll set this up. If you want to go ahead and pause the video, you may do so to see if the remainder is 0. So when I do this, this is going to be my result for my synthetic division. And because my remainder here is 0, that means x minus 1 goes into f of x evenly, so therefore is going to be a factor. And so my justification, I would simply say, since 0 is the remainder when dividing f of x by x minus 1, then according to the factor theorem, x minus 1 must be a factor of f of x. And that's it for this page.